Hi everyone, and welcome again. In this video I want to go over the dot product. So first of all, let's go over the definition, and let's do in Rn. The dot product of U, so if you're given two vectors and V, these are the components of U and these are the components of V, is the scalar, is a scalar first of all, and is found by multiplying the corresponding components of the two vectors and adding all the products. What do I mean by that? That's how you write it. U dot V is U1 V1 corresponding components plus U2 V2 plus dot 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 UN Vn. If you want to use summation notation, you can say U dot V sum of I starting from 1 to n Ui times Vi, and these are simple multiplications. I did an example here for you. If this is in R3, it could be in R4, R5, or Rn. If we have U, the components are 1, 2, 3, and we have V, the components are 3, 2, 1. So U dot V is going to be sum of Ui, Vi, I starting from 1 to 3. We stop at 3 because we are in R3. So it's going to be 1 times 3 plus 2 times 2 plus 3 times 1. And if you do that, and add those numbers, you get 10. And don't forget, it's a scalar. Now, dot product has properties. Let's go over those. U dot V is the same as V dot U. U dot V plus W is the same thing as U dot V plus U dot W, distributive property. When you have a scalar or a constant times U dot V, can be written as Cu dot V and U times U dot Cv. Number 4 is pretty important. U dot U is the norm of U squared. So again, this is the norm of U. Norm of U squared. Why? Because norm of U squared, I did that in my last video. Please watch it. Is U1 squared plus U2 squared plus dot 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 UN squared. And if you dot a vector by itself is U1 times U1, which is U1 squared, U2 times U2, which is U2 squared, and of course plus, and then you add them. So these two are the same thing. And I put where U is the magnitude of U, or the norm of U, or the length of U. U dot U, or a vector dot itself, is always greater or equal to 0. And U dot U is equal to 0 if and only if you're dealing with the 0 vector, or U equals to 0. Now you can prove all the above properties by using this formula or the components of vectors. And if you write it one by one, they can be proven. Next, let's talk about the dot product and the angle between two vectors. Now to find that, I want to refresh your memories of law of cosines, which we learned in trigonometry or geometry. If you have a scaling triangle, a squared, that side squared is going to be b squared plus c squared minus 2 times bc, and cosine of a. That means cosine of the angle opposite to the side of a. B squared works the same way. B squared is going to be a squared plus c squared minus 2 times a times c times cosine of that angle, which is the angle opposite to b, and same thing for c squared. Now, why did I do that? Because with vectors, we learned vector subtraction. So if you will subtract two vector, the resultant is this vector, which makes it a triangle. So I said this is norm of U, that's norm of V, and of course this is going to be the norm of U minus V. And theta is always between 0 and pi, or 180 degrees. Now if you use the law of triangle, the law of cosines for this one, we know that this squared is going to be U squared plus V squared, minus u times v cosine of theta cosine of this angle, which is the opposite of that side. Same formula. So these are, we use law of cosines. Now let's see what happens. So first of all, u minus v squared is the same thing as u minus v dot u minus v, and that comes from this formula. U minus v is a vector itself, so you can change this to dot product notation. Norm of u squared is u dot u, norm of v squared is v dot v minus, and don't change that, we can just leave it like that. So if I use the FOIL method, this becomes u dot u minus u dot v minus u dot v plus v dot v. So you just use the FOIL method. And on this side, we have u dot u plus v dot v, but we have the same thing on both sides. U dot u cancels here with u dot u, and v dot v cancels here. Minus u dot v minus u dot v is minus 2 u dot v, and that equals to, again, that we don't change that term, we just bring it down. However, the negative 2's cancel, and then if you isolate cosine theta or divide both sides by norm of u times norm of v, you get cosine theta equals to u dot v over norm of u times norm of v. Summary of that, the angle between two vectors in Rn is, you can find it by using cosine theta equals to u dot v over norm of u times norm of v, or theta is going to be cosine inverse of that expression. And again, theta is between 0 and pi. Now, one important note here, if theta is pi over 2 or theta is 90 degree, we know that cosine pi over 2 or cosine 90 equals to 0. So then we know that u dot v will be u dot v will be equal to 0. So how do we say that? Two vectors in Rn are orthogonal. Orthogonal, you have heard perpendicular, but in linear algebra we use orthogonal. That's the symbol, or if they're 90 degrees, then their dot product will be equal to 0. To check that, you can take two vectors with the components and then the angle is 90 degree between them, and then just do the dot product. You'll see you're gonna get 0 when you do the dot product. Very important when we talk about orthogonal vectors, because we're gonna see that in our future lectures. I think that's it for this lecture. In the next lecture, I'm gonna write the proof for Cauchy-Schwarz and triangular inequality. Thank you for watching, and I'll see you in my next video. Bye-bye.